Hello friends, today let us try to understand two concepts, surface area and a volume for any three-dimensional diagram. First of all, let us try to understand the difference between these two by having two examples. It is the cube and a cuboid. We are very familiar with these two concepts, cube and cuboid. So these are the two three-dimensional diagrams. Now if you consider this cuboid, it has a length, it has breadth, and it has height. So these three dimensions are there for a cuboid. That's why it is a three-dimensional diagram. On the other hand, if we consider a cube, for a cube, the length which is equal to breadth which is equal to height. So this is the basic difference between cube and cuboid. For a cube, the length, breadth, and height are equal. On the other hand, for a cuboid, the length, breadth, and heights are different. Now, if you consider the surface area for both of these two concepts, we have the formula for total surface area of cuboid, that is 2 into bracket L into B plus B into H plus L into H. Basically, cuboid has 6 surfaces, and if we want the total surface area of a cuboid, we have to add the area of each of the surface, and modifying the formula we get this formula for total surface area of cuboid, that is 2 into bracket length into breadth plus breadth into height plus length into height. Now if we consider the same formula, that is the total surface area of a cube, and if we modify this formula by having the total surface area of a cuboid as the length, breadth, and height for cube are equal, that's why the total surface area of a cube we get 6 into L square. So basically the total surface area means the area of all the surfaces of any three-dimensional diagram. Now let's understand what is the volume of the solid. Suppose let us consider this cube and a cuboid or a right circular cylinder. These are the three-dimensional diagrams which occupy some space, and the space occupied by these three-dimensional diagrams is called as volume of the corresponding solids. So we have the definition. These solids occupy some space. The measure of the space occupied by a solid is called as the volume of the solid. So that is the difference between the surface area and volume of a solid. In short, volume of any solid is nothing but the space occupied by a certain solid. Now let us illustrate this concept by having one example. Suppose there is a cube given with length 1 centimeter, breadth 1 centimeter, and height is also 1 centimeter. As this is a cube, length, breadth, and height are equal. Now if we have to find the volume of this cube, then the space occupied by this cube, which has the length, breadth, and height 1 centimeter, which is written as 1 cubic centimeter, and it is written as 1 cc or 1 centimeter cube. Now suppose if you take 1 cube, volume of 1 cube is 1 centimeter cube. Now if we join another cube to it, then the volume will be 2 centimeter cube. If we join another one, we'll get the volume 3 centimeter cube. And in this way, if we go on adding the cubes on it, that much amount of space will be occupied by those diagrams. Now the total volume of this figure we are getting is 6 centimeter cube. We get this diagram, which is a cuboid with length 3 centimeter, the breadth is 2 centimeter, and the height is 1. So this is the cuboid, and if we use the formula for volume of a cuboid, we have the formula, that is L into B into H. So in this case, the length is 3, breadth is 2, and the height is 1. So 3 into 2 into 1, that's 6 centimeter cube. So in this way, we can have the volume of a cuboid, which is generated by having 6 small cubes. So this is how we can find the volume of any three-dimensional diagram given. Now let us find the formula for volume of cuboid. So for this one, consider a cuboid of length L, breadth B, and height H. Then the volume of this cuboid is given by the formula L into B into H. In the same way, suppose if we have a cube with length L centimeter. Now if we have to find the volume of a cube, we have to just replace the length, breadth and height in the formula for volume of cuboid by L. As it is a cube, the length, breadth and height are equal. So instead of length, breadth and height, we can write L into L into L. That can be written as volume of a cube is equal to L cube. So the formula for volume of a cube is generated by the formula for volume of a cuboid. Now let's solve one example based on this one. Find the volume of a box if its length, breadth and height are 20 centimeter, 10.5 centimeter and 8 centimeter respectively. So as there is one box is given, its shape must be a cuboidal shape. So for this cuboid, let us have the length as L, breadth B and height H. So in this case, the length is given to be 20 centimeter. The breadth of cuboid B is given to be 10.5 centimeter and the height is given to be 8 centimeter. We have to find the volume of a box. So we have the formula for volume of a cuboid, that is L into B into H. Now if we replace the values of L, B and H in this formula, we get 20 into 10.5 into 8. To multiply this, we get volume of this cuboid as 1680 cubic centimeter. So this is how we can solve some examples by using this formula. Now let us consider another three-dimensional diagram, that is a cylinder. For this cylinder, two circular bases are there. Let us consider the radius of those two circular bases br, as there are two equal circular bases. That's why the radius of those circular bases br, and let us consider the height of this circular cylinder as h. So if we have the values for these two variables, we can have the formula for surface area of a cylinder, and it is derived as the curved surface area of a cylinder, that is equal to the circumference of the circular base plus height of the cylinder. So if we do that, we get the curved surface area of the cylinder. And we know that the formula for circumference of a circular base or circumference of a circle, that is 2 pi r into, we have assumed the letter h for height of this cylinder, that is into h. So we get the formula 2 pi r h. So this is the formula for the curved surface area of cylinder. Now here we should note that this is only curved surface area of this cylinder, that is the area across this curved surface of the cylinder. We have not added here the area of two circular bases. So this is the curved surface area of a cylinder. We can find it by the formula 2 pi r h, where r is the radius and h is the height. Now we have the total surface area of the cylinder. If we add the areas of two circular bases to the curved surface area of the cylinder, we get the total surface area. So the total surface area of a cylinder, that is equal to curved surface area plus area of upper surface plus area of lower surface. And we know that both the surfaces, that is upper and lower, are the circular surfaces. So we have here curved surface area as it is plus two circular bases are there which are equal. That's why we have written here 2 into area of circular faces. So we have just derived the formula for curved surface area of a cylinder, that is 2 pi r h, plus formula for area of a circle is pi r square, and two circular bases are there. That's why we have written here 2 pi r square. Now from both of these two, if we take 2 pi r common, in bracket we have h plus r. So this is the formula for total surface area of the cylinder. This 2 pi r into bracket h plus r. Now let us know how to find the volume of a cylinder. This is the formula for volume of a cylinder. It is area of a base into height, and base of cylinder is circular. That's why we have to use here the formula for area of a circle, that is pi r square, into height is h. So if we multiply that, we get pi r square h. So this is the formula for volume of cylinder. Now let's solve an example based on these concepts. How much iron is needed to make a rod of length 90 centimeter and the diameter 1.4 centimeter? So suppose this is a rod we have to make with the length 90 centimeter and the diameter of this rod is given to be 1.4 centimeter. The question is how much iron is required to make such a rod with the length 90 centimeter and the diameter 1.4 centimeter. That means we have to find the volume of the iron required to make this. For this we have to find the volume of a circular cylinder. So we have the formula for volume of cylinder. It is we have just derived a formula as pi r square into h. We know the value of pi is 22 by 7 into, now here r is required. R is nothing but the radius for this cylinder, and here radius is not given, instead that diameter is given. So diameter is 1.4 centimeter and we know that radius is always half the diameter. That's why the radius would be 0.7 centimeter, which is half of 1.4. So here we should take value of r as 0.7 bracket square into, now h for a height. Now in this case the length of this rod is nothing but the height, and length is given to be 90 centimeter. That's why height of this cylinder is 90. Now if we simplify this, we get 22 by 7 into 0.7 bracket square is there, so we can have 0.7 twice and we have to multiply it into 90. If we divide here, we'll get 7 ones are, that is 0.1. Now on simplifying, we'll get 22 into, now the product of 0.1 into 0.7, that would be 0.07 into 90. Now if we multiply this, we get the final answer as 138.60 centimeter cube or cubic centimeter. So that much iron is required, a rod of length 90 centimeter and the diameter 1.4 centimeter. Let us have another question. Find the volume of cylinder if the circumference of the cylinder is 132 centimeter and height is 25 centimeter. Now in this question, the circumference of a circle is given. Let us suppose the radius of the cylinder is r and height is h. Now by having this, we can have the formula for circumference of a circle as 2 pi r, and this circumference is given to be 132. That is equal to 2 into, if we replace pi here, we'll get 22 by 7 into r. We are doing this to get the value of r, that is the radius, because the radius is not given, and to find the volume of a cylinder we need a radius. So that's why we are calculating this one. Now if we have 132 the left hand side as it is, and if we transfer 2 to the left hand side, it will become 1 by 2 into 22 by 7 coming to the left hand side, it will be 7 by 22, that is equal to r. Now if we divide by 22, we get 22 ones are and 22 six are 132, and if we again divide by 2, we get 2 threes are 6. It is 3 into 1 into 7, that's 21 is equal to r, and r is equal to 21 centimeter. Now we get the radius and height is given to be 25. By these two, now we can find the volume of this cylinder. So we have the formula for volume of cylinder as, the formula is volume of cylinder is pi r square h. We take value of pi 22 by 7 into r square, radius is 21 and its square is there, so we should take 21 into 21 into height is 25, that's 25. If we divide again, we get 7 threes are 21. Now if we take a product of all these terms, 22, 3, 21 and 25, the final product would be 34,650 centimeter cube or cubic centimeter. So this is the volume of the given cylinder. So this is how we can solve some examples by using the formula for surface area and the volume.